Hello everyone, welcome to Geonodes Daily series where I explore some of my ideas to help you tap into the potential of geometry nodes. And as you can see from this demo, today we will explore the possibilities of creating a holographic shader. I'm gonna show you that in a future video. And also we explore the potential of geometry nodes to play with splines to create this awesome effect you see here. So I'm going to show you, as you can see in this card here on the screen, how you can shrink wrap some wires to any mesh and achieve that effect from the demo. Before we start, one of the most useful way to support this channel is by purchasing the project files that I explore in my videos. To purchase those from Gumroad, and this project file will look like this. As you can see, you have a bunch of controls for the geometry node setup to choose the object on which you want to shrink wrap the wires, how many wires you want, a bunch of other controls for the wires, also for the animation on the wires and glowing dots that you saw, and also a wireframe that you can add on top. And on top of all of this, you get this cool shader that is connected to the geometry nodes and controlled by it, so you get that effect that you saw in the demo. But more about the shader in a future video. Today we will look at this setup that you see here. So let's start with a new file. And first look at how we will achieve this effect. So we will take a mesh. You can use any mesh. We will use here the monkey head. Yeah, I know it looks better than my drawing. And the idea is to take a circle and duplicate this circle to go all around our mesh, something like this, and then make that circles shrink wrap to the mesh. Once we did that, we can play with the wires to create that glowing effect. We can attach those glowing dots and make them all do all sorts of cool stuff. So that's gonna be the basic idea. So let's start with shrink wrap the wires to the mesh. For that, we will need the mesh. So let's take this monkey, Suzanne. We can drag and drop it into our setup. Let's plug it here, delete the input for now, and we can hide the original mesh. We will just play with this one here. So once we have this mesh, a few things that we can do. We can do a mesh subdivision surface and make it a little bit smoother, and then we can do set shade smooth. So now we have a very nice mesh into our setup. So like I said, first thing before we shrink wrap, we kind of have to have the wires. I kind of explored this idea a little bit in the water drops projects, and I kind of want to show you how you can do this thing here. So let's take a curved circle. I'm going to plug it into this frame, and for now let's just connect it to the output to see what we have. We have this. So like I said, we want to duplicate it and make it go around the mesh that we have here, this one. So let's the geometry, join geometry better, and do something like this. Awesome. One thing that is really important is to make sure that this circle it's bigger than the mesh, so that when we shrink wrap it, we'll have room to stick to the mesh, not start somewhere like this and cut the mesh, because otherwise this information will be lost in the shrink wrap. So at the end of the video, I'm gonna show you how you can do this in a procedural way when you don't know the size of the mesh, but for now we'll just put it manually like this. We will not need so many points for this. Something like this is just fine. We can hide the mesh for now. And the way to duplicate this, we have this cool node called duplicate elements, and this is what we will use. So now we can decide how many we want here. So let's say we want 100 duplicates, and as you can see, we lose our geometry, and there is a good reason for that. It's because we duplicated the points and we have a spline here. So let's switch it to spline. And as you can see, now we have 100 splines, but they are all at the same position. So it's time to rotate them. And for that, we can use a set position node, plug it here, and we can use this position in conjunction with the original one and do some stuff to it. So let's go to vector utilities, and we have this actually vector rotate. So the vector we want to rotate is the position, and we will want to play with this angle here and with the axis, or we can switch it to Euler, and this way we have the ability to rotate based on all the three axes. So how can we do this? Let me push this one a little bit, and I'm gonna use the index of these splines, remap it to 360 degrees in radians. So if we want to remap it, let's take a map range, and we want to map it in radians. So 6.283, it's going to be 360 degrees in radians. And we will take this value, and we can plug this this value now here into the rotation. And as you can see, nothing happens because we have to define this range here, not 0 to 1, but 0 and the maximum number of index. That will be this number. So let's take an integer. Where are you, integer? Here. Let's plug this value here, and then we can use this one here for the maximum. One thing we have to change, we have to subtract 1, and the reason is because we have 100 instances that go from 0 to 99 if we look here. So this is why we have to do this. As soon as we do this, we get this distribution of circles, and as you can see, even though we kind of did a random rotation, a sequential rotation, we have this hole going through our setup that will be visible when we do the shrink wrap, meaning these parts will not be covered. And you can use this to achieve a certain effect, but if you want an even distribution, we will have to add something to our setup. And that's something for this setup. It's simple, easy. We have to just use this invert button, and now we get a different distribution that covers the entire mesh, and that's gonna be okay for now. Of course, if you don't want something grid-like and you want to use like a more random approach, you can do something like let me show you. You can take a random value, switch this one to vector, and then you can do, let's say, Control Shift D for this one, cut this one here, let's plug this one here, and use this random for, I'm gonna switch this one from Euler to axis, and use this random value for the axis, and for the angle, we can use the same setup from here, and you get this result. So you can play with either this one or this one. And at the end, I'm going to show you how you can output a switch to decide which version that you want. But for now, I'm going to leave it like this. So let me okay, let me just select these nodes and push them aside. I'm gonna also make a frame for the input object and a frame for this, just for organizational purposes, and push it here. And we can start with the Shrinkwrap procedure. And for that, surprise, surprise, we will use another set position. And before we do the actual Shrinkwrap, let's think about something. Now we have splines, and we can definitely use splines to Shrinkwrap, but the problem with splines is that they have a tendency to close themselves. And if we do the Shrinkwrap using splines, they will close in the center. And of course, we can delete that point, but that's going to create a bunch of other problems for us. So the easiest thing to do would be to simply take this curve and turn it into a mesh here. And visually, nothing will change. But now, as you can see, we have edges and not splines. And now we can do our Shrinkwrap, and for that we will use the raycast node. So let's plug the hit position here, and everything disappears because we have to fill in a few data for this node. First, we need a target geometry, and that's going to be our monkey. So let's plug this one here. We already see something happening here, but not exactly what we want, because we have to fix this ray direction problem here. Let me show you what I mean. As of now, with this ray direction -1, that means that all the rays from this geometry is going to be pushed down. And that's going to give us this result here, because only the splines that are down will be affected. So what we actually want is to push a ray from the spline towards the mesh, something like this. So basically we want to use the normals. So let's input the normal, and that's going to be the normal of our data from here, those lines. And as you can see, nothing happens, and the reason for that is because we are now pushing rays this direction, and we want to do it opposite direction. So how can we invert the normals? Well, we can use a vector math node, switch this one to scale, for example, and do -1. And now when we activate this, we get this result that you see here. And it's still not it's not very good, because right now we don't have enough information here. We kind of have to subdivide these edges. So as soon as we do this, we start to get something that looks a lot better. So let me quickly align this one, and as you can see, as we increase this data, we get a more precise control. And now we have this surrounding our monkey head, as you can see here. So basically the Shrinkwrap is done. So let's move to the point 3 and do some animation. First thing I want to do is to make these lines that we created here to kind of wave while still be attached to the mesh being shrink wrap. That means that we have to do the animation before we do the shrink wrap. So let's duplicate this set position, plug it here, and now we are ready to do the animation. And the way I want to do the animation is by playing with this offset here that we get and do something procedural with that. So let me take a texture, noise texture. I'm gonna plug it here, put it in its own group, and then this output from here, I'm gonna plug it into this offset. And as soon as we do this, we get this result. And if we mute and unmute this node, we see what's going on. Let's do one thing that I always do it for the noise texture, and that is to subtract 0.5, just to make sure that the texture stays in place and don't get moved. And then we have to implement our movement. So for the movement, I'm going to use a scene time to get this frame data. And this is going to be somehow connected to this texture information. We can switch this one to 4D and animate the seed, but that's going to be expensive. And we can do a bunch of other stuff, but the way I want to control it is by playing with the intensity of this effect. So if I plug a math node and switch it to multiply here, we have this value that controls the intensity of the effect. So at 0 we have nothing, and as we increase this value, we get more and more of the effect. And basically this is what I want to do. I want this to go like this, get a little bit of waving. So first of all, I want to decrease the scale because I want a more subtle effect. And of course, we can play with these values and achieve whatever result you want. So I'm going to do something like this. This is what I want to do. So basically, we want an animation that will go from 0 to a certain value here. And it's going to be controlled by the frame. So given the fact that we kind of want to go back and forth like this, we can use a node, a function from the map node, and that is ping pong. That basically is going to go back and forth between a certain value that we want. And that value is going to be just how much distortion we want to add to this. So let's see. I used the 2 value that kind of look like this. So if we plug a 2 value here, and then we plug this one here, and the frame here, what we basically get is a back and forth between 0 and 2. So you're going to get something like this. Obviously, it's much too fast. So let's duplicate this ping pong node and switch it to multiply. And now we can control the speed from here. So now we can get something that is more reasonable. Something like this. Yeah, this is what I want. So let me just plug these ones here. And that's going to be the waving motion. Like I said at the beginning of the video, at the end I'm going to show you how I exposed some parameters. But for now, let's move on and do the growth wire effect. So for that, we will move after the shrink wrap. So after this part, and in order to get this growth wire, the easiest way to do it is to use this trim curve node. But right now we don't have curves anymore. We have a pure mesh. So let's go now to curve and do curve. Sorry, go to mesh and do mesh to curve. And now we can use this one again because we are back to a curve output. So now we can play with these values. And as you can see, nothing happens. And the reason for that is because our curves are closed. We have this cyclic here that it's on 1. And that means this is not going to work. We have to open the curves first. So first thing we need to do is to add this set spline cyclic node here before this string curve. Let me just move these 3 nodes here. And now we can just do this, as you can see. So if we go from 0 to 1, we do some animation on this, we can open and close all the curves at the same time. After we do that, I'm going to show you how you can offset this. But first, let's do the animation part. And because I want to control when we start and when we end this animation, let me get to frame 1. I'm going to do the scene time, plug it here. And now we can control the start and end of the effect. So let's say frame 10 to frame 120. And the output should be 0 to 1. Excellent. If we plug this one here, until frame 10, nothing happens. And at frame 11, we start to get our animation. So that's the base of what we need to do. And now it's time to develop that. So how can we add a delay between frame start? Well, as you can see, we have this diamond-shaped socket. That means that we can pass different value for each and every single spline that we have here. And one easy way to do that is to simply introduce to our setup a random value. So let's go to utilities, add a random value. And the way to introduce it to our setup is by using a math node and plug it here. And let's see what happens. Everything seems to go again at the same time. Let me put this one to frame 1. So things doesn't seem to work. That's because we are adding a value, but we have this clump to 0 to 1 range. So this is not what we want to achieve. So let's do a subtraction, and as you can see, we kind of get a little bit of delay, but not enough. Because what we need to do is change this value here. So we have to correlate this maximum number with this maximum number here. So that's kind of easy. Let's take a value node and plug it here. And let's plug this 120 to this maximum here and to this maximum here. And as soon as we do this, check out what happens. We get this nice delay. And that's going to be the basis for the animation. At the end, I'm going to show you my final setup where I did a little bit of correlation here to make sure that this end frame actually ends the animation, because right now it's not doing that. If we get to 120, not all the frames are closed. We kind of have to increase this value. Let's put 500 frames. And if we do this at some point, basically when this random value last one hits, we will have all the splines closed. But we leave it like this for now. One more thing that we need to do now is to add the dots that you saw in the demo and make them follow the wires. And also we want to make it so not every single spline here gets a dot. That's not what we want. So let's move on to that point now. Let's ask ourselves the following question. How can we make the dots appear only when the spline is closed? So we don't want the dots to appear on these splines. We want to appear only on a spline that has already finished its cycle and it's closed. And if we look closely here at this, let me find it. Right now, as you can see, our splines are not exactly closed. I try to get to a point where you can actually see this. They kind of have gaps because let me see, do something like this. At this point, everything should be closed, but if we play with this value, depending on the resolution of the spline, yeah, we can see it here. See, the splines are not actually closed. And if the resolution of them is smaller, this gap will be more obvious. So we have a way to actually make the dots appear when the splines are closed, and to also close these splines in a procedural way. And that way is to check the output of this value. You remember it's a 0 to 1 factor, and 1 is when the animation is finished. So if we introduce a comparison node, and we take this output that, remember, it's unique for each and every spline, and say it's equal to 1, meaning the animation is over, then we can plug this result here into the cyclic, and that's going to close the splines and also keep the animation working. As you can see, it's still working, because this is going to be true only for the splines that have a value of 1 here, and meaning the animation is already finished. So when we close the spline, and all the other splines will be open. So that's it's going to give us an information that we can actually use for our setup for dots. That is going to work like this: instance on points. So we want to take these points from here and plug it here, and let's change to a frame like this. And for the instance, let's use a icosphere. I'm gonna plug it into the instance and decrease the radius, something like 0.05 maybe. And once we did this, we have this cool node called curve curve is spline cyclic. That it's a boolean that we can plug here, and it's gonna make sure that we instance points only if the spline is closed, and it's gonna be closed when the animation is over for it. So let's move like this, and you can see now we have a bunch of dots here, too many, and the reason for that is that we basically instance a point, an icosphere on each point of that spline, and we don't want that. We want to instance only on the last point, and for that we have another node called endpoint selection that can be used for that. So let's see what's going to happen if we use this one. We basically can select only the start point of the splines, and now we have to combine it with this logic. So let's do a boolean math, and if the spline is cyclic and it's just the endpoint, it's gonna be what we want. And now, as you can see, only the closed splines will get a dot. Awesome. So now with this setup, if a spline is cyclic and meaning its animation is closed, we will instance on its start point a dot. But I want to add something else to be set up. I want to randomly choose only some of the splines, not all. And for that, we can do another Boolean math. So let's switch this one to OR, and for this, we will add a random value. And as soon as we do this, we can basically combine these conditions. If you take a close look at this result here, and you look at the balls, you see that they keep popping in and out, and that's a problem that is caused by the fact that this data is keep changing as we get new splines that correspond to this condition. So how can we fix that? Well, let's eliminate the splines that don't correspond to this position, and then only those splines will be used here for instancing. That's gonna help us get rid of that popping. So let's do a delete geometry, switch the domain to spline, and now we can use this condition that we created here to select some of these splines. So if we go to the beginning, now we see basically, let's get rid of this condition, we don't need it. We see this result. We kind of keep only the splines that are basically not closed. So we kind of want to invert this. So let's do Boolean math and switch it to invert it. And instead of having this condition and this condition true, let's make it this condition or this condition true. And now, yeah, as you can see, we just get new data as more splines gets closed, but we don't get the popping. And if we want to decrease the number of final dots, we can play with this value. Playing with this Boolean math can be a little bit confusing at first, so you can just do trial and error until you intuitively start to understand how it's working. What we are doing here, we are looking only at the data that it's not cyclic, meaning it's not done, and we delete those data, or we delete those data that correspond to this random value. That's how it's working. And then on the end, in order not to output on each and every single point of the splines that get selected here, these 18 splines, we use this boolean here to only instance on the start point. That's how this works. So once we did that, we want to animate the points. And the way to animate them, we know that they are at the end, at the start of the spline. It's to simply add a trim curve. So if we add a trim curve here, and we start to play with the start value or the end value, the start value, nothing happens. And that's because, again, this data is composed of curves that are cyclic, meaning they are closed. So again, we have to use this node, and now we can play with this to move the points around, as you can see, the start, because they are at the start. So as we trim the curves again, the curves that, remember, at this point we are only using to instance those points. So if we trim the start, we basically move the points around. So this is how we will do the animation. So let's take again a scene time node, and then let's make the animation cyclic by adding a math node, and we basically want to go up and around, up and around, up and around. And for that, we can use, for example, the modulo, and we can put it on 1. So that means that we will cycle between 0 and 1. So if we plug this one here and we plug this one here, we get this animation. That is obviously way too fast. So we can do in another math node a multiply, and let's do a 0.1, for example, and now everything moves here. And if we want to add more variation, we can do a random value here, and let's say from 0.01 to 0.1, and that's going to be our multiplying factor, and that's going to give a different multiplying factor for each and every point here, because again, diamond shape, we have these 18 instances. That means that's going to give us 18 different values, random values between 0.01 and 0.1. So the result is going to be this one that you see here. So we get the splines to grow, and then we get points instance on those splines, and those points start to move around. And as you can see, at some point, that's the final problem that we will fix. Let's show you. See, we kind of get this jump. I kind of want to fix that, and for that, I'm gonna do a closing on the splines again. So let's do compare node to plug on this set spline cyclic here, and the condition will be looking at this value from here, and if it's equal to 1, then the spline will get close. So right now, if we look at the animation, it doesn't look that jumpy anymore. Okay, this again, it's another long tutorial. I would really like to know what you guys want. If you prefer to get all these details, or you prefer something quicker, please let me know in the comments. I can try to skip some of the steps, just show you the node tree, or just show you the general idea without the details. If you let me know what you would prefer, I will try to do things in a way that will be more interesting for you. For example, in this setup, you can also play with the scale and do different sides of the dots and stuff like that. But that's something that I'm going to show you in this recap that we will do on the final project file. So you can see a cleanup node tree with labels and all the good stuff. So that's going to be again the project file that you find on Gumroad with all these parameters here that you see. And I'm going to show you how you can get to that. So for the hero mesh, we have this object info, and I expose the object, so you can choose whatever mesh you want. You have this subdivision level. It's not exposed to keep this number of parameters shorter, but it has a green color, so you can easily find the areas where you have something to modify. And what I did, apart from what I show you in the video, I added this turning into wireframe that will add basically a wireframe on top of everything else. If I go to somewhere like closer to the end, something like this, as you can see, we have this wireframe here. That's this part. Without it, we don't have it anymore. So this is added here. Of course, we have the original mesh that uses the hologram material. I'm going to show you all of that in making of the project video, so make sure to check for that one. And like I said you at the beginning, if you plug another mesh, you don't know how big or small it is. So in order to make sure that everything shrink wraps correctly, I took this mesh that we inputted here and look at the bounding box, checked out a diagonal on it. Basically, this is the bounding box, and this setup is just looking at this diagonal by subtracting from the minimum, from the maximum the minimum. And this information is used for the radius of the circle that was originally used to create this shrink wrap wire effect. You see the number of wires here, resolution that it's used here. It's just exposing this parameter. You can just on the input, you can simply drag and drop any value here, and once you do this, you press the N button to open the N panel. Let me quickly do screencast keys. Okay. And then you open the N panel, go to the group tab, and you can play with the settings of these new inputs that you create, meaning you choose the type, you choose the range, you choose the default value, you can put a tooltip and all that good stuff. So this is what I did here. And for the wire thickness, of course, we can control that also. And the thickness, if I'm looking here, should be at the end where we have this turn to mesh. So we take these wires, do a curve to mesh on them, we put a circle on it, and I did this wire thickness where I created this let me switch to a material preview. I created this control that can be used to decide just how thick you want these wires that grow to be. So if we go to a frame like this, for example, you can better see what's going on. You can make this as thick as you want, or if you press hover over the value and you press backspace, you can go to the default value. So this thickness, of course, it's a much smaller number in reality. That's why it's divided by 1000. And then we have this parameter random distribution that was used here to decide how you want the wires to go on your mesh. You want them to be a more grid-like pattern, something like this, or you want them to be more random like this. And that's basically switching between these two methods that I showed you during the video. And that's gonna be a grid-like distribution here or random distribution here. And then you use a switch on the vector and output this boolean here. Then the raw precision is just exposing this value from the Shrinkwrap. That is basically the subdivision. And when you have these values where you start and end the animation exposed here, this one, start and end. And this is interesting. I want to show you. Our animation, as you can see, ends at the frame 480. And if you look at the number of instances, meaning how many glowing dots you have, if you go further, this is not going to increase because our animation is actually ending at this frame. And the way to achieve that, as you saw in the video, we did this entire thing for a trim curve to do the growing effect, and we added the delay by subtracting from this maximum value something, a random value, this one. And this is the setup to make sure that everything actually ends at the frame 480. I'm going to explain it to you. So we have the scene time. Then from that we subtract a random value. That's going to be this delay that I turn it into a 0 to 1 factor. And the actual number that we use is actually the end frame divided by 2. So if we have this maximum number of delay, that's going to be half of this number, meaning 240 in this case, that it's being going to be output here in the random range, and that's going to be subtracted from the frame, and this is going to be from minimum you decide to maximum. And this maximum, that's the important part, it's not going to be the end frame 480, it's going to be that number minus whatever number we have here as an output. So in this case we have 240, but if we do this delay, let's say half of it, we're gonna get a maximum output of 120. That's gonna be subtracted from this and gonna give us the maximum number of the frame where the animation actually gonna end. So in the end, that means that our animation is actually going to end at this frame, because we will always account for the delay here, and this now random value that we will subtract will always be even added to this number amount to this value. So this is what we did. Again, we have the final number that we see here, and we subtract from this one whatever delay we set up to make sure that the wire's growth end frame is going to be finishing before we do all these delays. And after that, we add as a delay whatever is left. So we will end up at this frame. I hope I managed to explain. If it's not clear, you just look at this note tree or you ask me, and I'm going to try to write it down for you and make it easier to understand. Of course, we have this delay seed that controls the random value, and that's going to help you change the pattern of growth to get something else. So when we go like this, if we play with this seed, we get different starting and ending. And then we have controls for the waving speed and intensity, and that's gonna be another purple frame, this one here. So the waving speed is simply controlled, as you can see here, controlling the speed of the waving. And of course you can control the intensity by playing with this value. This value here. So I'm going to show you how you can connect it, because it's not connected. You just plug it here into the waving intensity, and now you can control the intensity from here. Awesome. Again, we have a seed that you can control for the sparks. So we go to the points here, and we have this random cutting of the splines here, and this seed is exposed here, and you can change the pattern. So if we move to a frame where we have some dots, like maybe here, playing with this seed is going to give you different distribution of points. And the spark amount, of course, it's controlling this value from here, just that controls this boolean here. And then you have the speed minimum and maximum for this animation here. Again, just some control for the minimum and maximum of this random value that controls the speed, and the seed to change the pattern of movement. And then we have this random size control of the sparks here that controls the random size of the sparks. And the wireframe thickness, that's going to be this one that we see here, wireframe thickness. Again, it's actually a much smaller number that I divided by 10,000 in order to get something more manageable here. So one thing that I want to show you regarding connecting the holographic shader to this, because we have this shader here that takes into account what's going on with the animation by using this attribute here. More of that shader in the making of the project video, but for this one the idea is that we have this value exposed called fx factor, and the way it's working, it's taking the scene time, map range, minimum and maximum of the animation, and it's turning into a 0 to 1 factor that we can use on the shader. And also you can see this is important to complete this name here, the same that you will use in this shader here. This name here must be exactly the same as this name here. Otherwise, this is not going to work. And you can see I exposed another value that it's actually responsible for what you see on these wires, this variation in intensity. And that's, again, if we look at this output, I exposed a float on the point domain with the value between 0 and 1. And if we follow this noodle, let's do a reroute and just do something like this. We have this plugged here. We capture an attribute with a random value on this mesh curve that we used for the wires that you see here. This is after we did the shrink wrap. So this is how this is working. I guess this is ended up being a very long video. I hope that's okay with you. If not, let me know. But I kind of covered everything I want to cover from this project. Thank you very much for watching this video. Please leave your comments in the comments section, your feedback. It's really important for me to know what you want, because I want to make better videos for you. And also thank you for all of you that subscribe